This conference will now be recorded.
Right. Okay, guys. To introduce myself Ravinder. I'm working on SQL DBA last 13 years, and I'm working on MongoDB last 6 years, and also I'm working on Azure SQL DBA also last 6 years. So I do handle other technologies as well along with this. I'm expertised into these three technologies. Along with this, I do work on Postgres as well. So just to introduce myself, that is what about myself. So we're going to see today what is MongoDB, why we need to learn NoSQL technology, one of the NoSQL technology, to bring into our profile. What is the necessity to learn these technologies? We are going to see a lot of in detail of content of it. So first, let's talk about what is MongoDB and why it is so important to learn. What are the use cases it is solving in the in the real world? So where why it is getting implemented. All that we're going to see it. So what is NoSQL? Basically, it is something we have RDBMS systems. RDBMS systems are always will follow some structured, in the background you have to define the structure, then load the data. NoSQL is not like that. It is a quite reverse of that. You don't have to define any structure, it will pick up any kind of data basically. So why NoSQL required? Basically, RDBMS products are so sophisticated technologies nowadays, since 1980s people are using it successfully. Why nowadays we are slowly moving to NoSQL technology side. So that is also will be explained in the class. This is the objective of the course today anyway. We're going to talk about why we need to learn this and why this is giving what kind of benefits it is giving exactly. Benefits over the RDBMS. If you compare with RDBMS, what are the major benefits we are getting from this MongoDB? You're going to see it. And NoSQL and RDBMS terminologies, like what do we call, what are the options we have, in terms of, like database, tables, rows, columns, all that we have, right? What are the terminologies we use in the MongoDB? We're going to talk about that. Different types of NoSQL databases. Like we have in RDBMS a lot of technologies, right? Like Oracle, SQL Server, Postgres, MySQL, Greenplum, like that. In MongoDB, in NoSQL as well, we have a lot of technologies, like 20 plus technologies. But MongoDB is actually, serving a lot of business use cases. That is the reason it is getting implemented. Anyway, the next major discussion is all about the MongoDB anyway. RDBMS will follow the ACID, ACID properties to fulfill the data consistency, and this NoSQL technology will follow the base property to fulfill the data consistency. What are these? Basically, we're going to see at the end of the discussion, in detail of it. Okay. And the CAP theorem. CAP theorem is something every product should follow the one of the CAP theorem model to to showcase the data is consistent all the time, and data server is available, and availability, and there was it should follow availability as well as the data consistency. Two things are very important for any technology. Okay, that is also will be covered under the CAP theorem. Let's look at the NoSQL family, how it is kind of. See here, NoSQL was introduced by Carl Strozzi in 1998. Actually, this was introduced long ago, but there was no response from the market because they were not dependent on the NoSQL family databases during that time. So before RDBM systems are involved, people used to write the write the information on the papers. So that is going go, after a few days, after some years, it is the information become more and more. They need the they need the excels, and they need the notepads. They used to write the information in normal without rdbm systems. So when the information is more, they used to be have a relations. You need to have example, if you are running a college, one person will enroll into multiple courses. Data getting duplicated, searching the information become very tough. So that's where the RDBM systems are introduced. RDBM systems are serve the purpose till 2010 kind of. So after 2010, see nowadays if you see everyone have a the device in their hand. The sources of data become the sources of data become very vast nowadays. Like if you see before if you look at before 2010, what used to happen, you have a you don't have much of data generation. But now nowadays data generation become too much, and like the RDBM is not going to handle that data. So what I mean to say, so if nowadays data is getting generated in different formats like structured, semi-structured, unstructured, all that. So if you look at Facebook or Twitter and all, you can upload any kind of data there. The platform is actually open for any kind of data. You upload like structured data, semi-structured data, and you can upload videos, PDFs, photos, and the number of people are hitting the application is also very vast. When the RDBMS actually, when the data grows really large, it won't support the like the computing power basically in the background. First, what I'll do, I'm going to talk about what is the RDBMS architecture and NoSQL architecture. Then I'll come to each slide so that it will be easy for you to understand, very easy for you to understand. First, let me discuss about the architectures, guys, quickly, because this will take you to the actual content of the slides. So I'll just wanted to clear it out quickly and then move to the slides so that it will be easy for all of you to understand. See, if it is RDBM system, what happens basically, like RDBM system, you will have a standalone machine generally to write the data. One server will respond all the time. Only one server will respond. You will, if your data is more and more, what do? You'll add more and more drives onto the system. If the data is again occupying all the drives, what do? You'll extend the drive. You'll extend the drive to load like more and more data. But again, if the data becomes more and more, what happens? Even the IO will get choked up. If you load all the data into few disks, again, what do? You will add some more drives. Some more drives, you add it and stripe the data. At the same time, to sustain with the high load of data, you're going to add more and more CPUs to the system. Okay, within the system, this is within the system. So as you are adding more and more CPUs, you have to pay core based licensing model. All RDBM systems are core based licensing model. They don't follow like how much data you have, it kind of how many cores you are deploying on the machine. If I look at my laptop, so let me show this quick example. If I look at my laptop, I have 8 cores basically, one socket and four physical CPUs, one physical CPU, one socket. On top of it, four CPUs are there, and four CPUs again divided into 8 logical CPUs. I had to pay for the 8 licenses if I use SQL Server in my machine. So NoSQLs are not like that. They are RAM-based licensing model, not core-based. Again, it is a open source. No, all NoSQLs are open source. Anyway, I'm going to pick up that open source, discussion in the slides. So try to understand. If your data is growing more and more in a single server, what happens if you load example 10 TB of data in a single database? What happens? You cannot do the maintenance like rebuilding the indexes, reorganizing the indexes. You cannot do it on timely basis. Why? Because rebuilding itself is take days and days of time. Days of time that business cannot afford to give you that big window to do the rebuilding indexes on the tables. If you don't do it, what happens? Performance will degrade to a really worse level. That should not happen. So as data is growing and growing on a single system, you cannot manage in the RDBM system. And also RDBM is always a fixed schema model. It does not follow the dynamic schema model. So dynamic schema means, so let me quickly talk about this. Just to explain this, just this is kind of background, guys. Once I show you a few things, then I'll enter into the slides anyway. So if it is RDBM system, what happens basically? If I go to the database, if I create a one table, just for the sake of discussion, I'm just creating one table. Try to follow this first, then I'll come to the slides. Slides are easy to follow if you understand this. So I'm creating one table with some structure in the background. Right, so if I see, I created a table. If I wanted to insert the data, I have to follow the structure what I defined to enter the data inside this RDBM systems all the time. You have 3 columns. You must follow that structure to enter the data basically. So if I wanted to enter the data into insert into, I'm going to talk about this, why I'm telling this. Insert into student values. Example, I'm entering one record like Ravinder. So I'm inserting this one. It is going to pick up that record. Why? Because it's following the structure. If I do the extra next column entry, like I'm going to give some phone number kind of, okay, some entry, some the column which does not is not defined. If I'm trying to do this, it is going to throw the error. The column name and the number of supplied values does not match. It always, go with a fixed structure model. You have to define the structure, then load the data. MongoDB is not like that. This is one more important point why people are using this technology a lot in the market. I'll just quickly show this, just a minute. So I enter into the Mongo. I have Mongo in in this machine. Just a minute. Who is this sending the message? Guys, I'll pick up the questions, just try to follow. I'll pick up the questions anyway. So I entered into the Mongo. I installed the Mongo anyway. No need to worry. I'm going to run through the right from the beginning to advanced level. How do we install the product? How do we configure? How do we troubleshoot in detail of it? But right now, quickly, we'll talk about this, how Mongo accept the data, irrespective of the data format, quickly. So if you see show DBs, I have some default databases. So MongoDB does not require you to create a database directly. It will create the database on the fly. It will create the collection on the fly. Everything is on the fly. It is a schema-less product. Anything you load, it will accept automatically. Anyway, we can keep the restrictions. There is something called it schema design. We can build a schema, like REST validations, then pick up the data. That something comes in the fifth module, schema design. Like what you wanted, what kind of data you wanted to accept. Mongo by default will not restrict any data format. Any data format it will accept. So what I mean by that? So use example SQLDB database example. So just use itself will create the database automatically. And I'm going to insert some data. db.test.insert. I'm inserting some data. Data will be in the JSON format. No need to worry, JSON format. I'm going to explain you in detail. It is very simple language anyway. So I'm inserting some record into it. So I inserted one record. If I see show collections, it will show me that, like what is I have inserted. I mean, what is I created? Test. It is a TES actually. If I read the data, you have one object which is S number, S name. Now what I'm going to do in the next record, I'm going to add one extra field, phone number. It does not need any definition. It will accept any kind of data. So if I read the same data again, you see the second record. Second record is following a different column structure. Here you have two fields or two columns. Okay, here you have three fields. I did not define anything. If example, if I'm trying to insert one more record along with it, so address, something like this. So now if you see third record is also absolutely different structure, and this one following the different structure, and this one is following the different structure. So any kind of structure MongoDB will accept. It can be structured, unstructured, any kind of data. It does not reject any kind of data you feed into the system. And also if you see show collections, I have one collection right now. Okay, come on, sorry. If you see show collection, we have only one collection right now. So if I wanted to create one more collection, what happened? What it is saying collection, show collections actually. Oh really? Right, we have only one collection. If I wanted to create one more collection on the fly, if application is sending a new data without any defining a structure in the background, if it is a RDBMS, what you have to do first, you have to create the object and define the structure and send the data of that structure only. If you are not following the structure, what automatically it will throw the errors like this. First you define the structure, then load the data. If it is RDBMS system, any NoSQL technology, no need to define any structure. It just takes the data in the background as you are sending it. If example, I wanted to go with the db.class, okay, insert. class does not exist. Show collection, we have only TES collection. Right now I'm inserting a data into class collection, class table kind of thing here. So I entered one record just to see that, if you see the here, sorry guys, it's my typing mistake. So if you see, the collection got created, I mean the table got created. You no need to create any structure. You no need to even define the table in the background. If you are supplying the new data with a different collection, it automatically create the structure, automatically create the collection and take the data as it is coming in with whatever the format it is coming into the system. So this is something called schema-less products. All NoSQL products will follow the schema-less products basically. They no need to follow the structure. You just feed the data, whatever the data you have in your business model, it will pick up the data. That's what in nowadays, the data formats are different. A wide variety of data is getting generated from the market. You cannot deal with RDBMS system all this data. Always RDBMS what is doing actually, you need to define the structure and enter the data, then only it is picking up the data from the background. If your applications are agile nature, like every day you are seeing a different requirement, a different field set you wanted in the application side, and you have to define the structure first and then load the data. So that is not going to be, nowadays people are very agile. They wanted immediately any new chain that need to be deployed. So RDBMs are fixed. If example, if I have 1 TB table, if you wanted to alter the table structure, it takes quite a long, like it takes a lot of downtime on the table. Why? Because it is going to take a hell lot of time to change the structure of the table, what you have already on the system. So MongoDB is something, it is on the fly, it is going to change the structures on the fly, it is going to take the data, and it is going to accept structured, semi-structured, and unstructured, like anything, any kind of data, any kind of formats, it is going to accept basically. So NoSQL represents a group of products and various related data concepts for storage and management of large data sets. Actually, it has multiple technologies to deal with the large data sets. If I come back to this one, guys, if it is RDBM system, it is a standalone machine. It is a standalone machine, RDBM system, if you talk about. Okay, in RDBM system, always you write one data into one server only. You might be having a standby server, as a if one server goes down, other server will take up the load. That is good enough. But any point of time, you can write the data into one server only. That one server, if down the line it becomes very big, doing the maintenance is not going to work for you. Like one table is becoming 1 TB, doing the rebuilding index, reorganizing index, update statistic easy enough, it will go quickly. But rebuilding, reorganizing is going to take hell lot of time. So business cannot afford. See, if it is 1 TB table, if you are doing the rebuilding, it might take a day or more than a day. So they cannot afford to give the complete downtime on the table for more than a day, right? So if you don't do the maintenance again, you don't get the performance. So that is another big disadvantage with the RDBMS systems. If example, if your database one server one, you have only standalone. If one server is down, you're gone. Even if you have a standalone anyway, standalone will just keep the copy of the data, but it is not letting you to write. If you go to the MongoDB architecture, how it is going to operate, the MongoDB, how it is going to scale with the enormous data, like petabytes of data, zettabytes of data, it will scale up. How it scale up? Basically, it will follow the replica set configuration. It's like a traditional RDBMS system. Whatever you load into one system, automatically it will replicate to two more machines. It's kind of data when you have the data under control, you run with a one write machine, two standby machines. If this goes down, automatically it will pick up the data. When the data becomes more and more and becomes vast, I'll introduce one more set of replica set into the configuration and form the sharding. Just try to follow. This is where I'm going to conclude architecture and then come to the slides. So whatever the data, if example I have 100 TB here, 100 TB data in the first replica set. So if I add one more replica set in the background, it will share the data automatically, 50 TB here and the 50 TB here. Automatically it will share the data automatically. And if this becomes again, big enough, again I'll do, I'll add one more set of replica set. Automatically the 100 GB will become 32 TB, 32 TB, 33 TB, 33 TB, equally it will distribute. So when it is distributing the data, how it can accessible, how data can be accessible from each replication, each replica set. Let me anyway give you fair idea about this, guys. Then I'll talk about it. This is something called config servers, and you'll have a router servers. Router servers in turn will connect through the applications. Applications will hit the router servers. I'll explain the architecture. This is where you get the benefit of these products. NoSQL family. NoSQL family always will follow this kind of architecture in the background. So these are the application servers. This is a Mongoose. I'll quickly explain this architecture. Then you understand how MongoDB is going to scale with a large, enormous data. Config
So,
servers.
Ravinder, I have a question.
Yeah.
So when you are creating a second set of replica, so initially you said it's 100 TB, and
Okay.
when the second set of replica has been created, it is going to
Mm,
split into 50 TB, 50 TB. So
right.
technically, it's not going to fill the first one and then start writing on the second one, but it's going to split as many replica you are going to create.
Right. See, it is actually independent 50 TB data. This is another 50 TB data, and it has a copy, exact 50 TB copy here and here again as a fail safe. Like you have the data is 100 TB is split into 50-50 here, and the other 50 is handled in this replica set, and it has again copy of it exactly. And where the data is sitting, what chunk, what like you have 100 TB and other 50 TB here, 50 TB here. Who is actually going to redirect you? You have the data, some data here, some data here, the config server. All data address like metadata, complete data address will sit with the config server. First, what happens? Application will hit the Mongoose server. Mongoose is like a router. It will contact the config server. Config server knows where the data lying inside the replica set, inside the background, where the data, actual data is sitting here, and then it will give you the address. Through that address, it will fetch the data and give it to the application. So what is the benefit here basically? First I have 100 TB. Now my machines are struggling with the performance. Why? Because all of data you loaded into one replica set. So what I'm to get with the good performance, I introduce one more replica set. So 100 TB is divided into 50 TB, 50 TB. Good enough. The performance gained, and data is again growing slowly. Then I'm going to introduce one more replica set. It become example 120 TB altogether, 60 TB, 60 TB. Again, we are seeing the performance issue. Then I had introduced one more. So it will again distribute into 40 TB, 40 TB, 40 TB, automatic. When you add the replica set, it will rebalance the data in the background. You don't need to do that. Just add the replica set, it will pick up the data and stripe the data into new replica model what you're giving it. If I data is keep growing again, I'll keep adding the replica sets in the background. So data is actually distributed to multiple server. All these are writable nodes. Actually all these four are writable nodes. These are the standby nodes for each one. So what happens in this technology, even this goes down for some reason, it will automatically do the failover and start as like a primary automatically. So you're writing the data into, literally writing into four different servers in the background what you're writing. If I'm reading some data also, you are reading from four different servers from the background. So that irrespective of the data size, the servers will automatically scale with the performance. Why? Because multiple servers. What are the replica sets? Replica set is something, it is a, you're keeping the data, you're dividing your data. Replica set, we need it in the background. See, you can keep one MongoD, one MongoD, one MongoD, four MongoDs you can keep it, Mongo servers, and distribute the data. But if this is down, what happens? You lose the data. I mean, this whatever the data is sitting here, you cannot see from the application. It is not visible. Why? Because this machine is down. If it is a replica set is like always on in SQL server, in a rack. If you pick up Oracle, it is a kind of a rack. If one server goes down, other server will be always available. You'll have in rack concept, what you do, you'll multiple servers you write in rack concept. Let me quickly talk about that as you asked. See, if it is SQL server, you can only write into one server. You cannot write into multiple server in any technology in a SQL server. But you can create multiple standbys. It is possible. Create multiple standbys so that one server goes down, other one will pick up. But at any point of time, you can only write into one machine only. It is not possible to write into multiple machines for a single application generally. If it is a rack concept, what happens? In rack is little different.
I
You can
have
write
a question.
yeah, go ahead, Marvin.
So the replica service that have MongoDB installed on them.
Right.
So let me ask you. So are you trying to tell me I have to, with the model you have there, I have to install 12 Mango? I have to like create 12 Mango servers?
Exactly. You have to create 12 Mongo servers to get this structure. Why we need it? You can run in the cheapest hardware, commodity hardware. You don't need a server class hardware to run the Mongos. You can run a cheapest on cheapest hardware. Why? Because it will scale, because you are distributing the data to multiple servers. You're striping the data to multiple servers, not to the disk. In the RDBMS, you write into multiple disks to get the good IO, but
Correct.
you are giving the power in terms of servers, not in terms of disk here. So
Okay.
though it is not server class hardware where you're creating in the background, it's just a desktop can scale with your data. Why? Because you are not loading everything into one server. You have hundreds of servers in the background to serve the huge data set. See, if you talk about Facebook or any other social platform, billions of people are loading the data and reading the data. You never see the downtime. The portal is going down. How that is going to scale up? That every social media or any platform, like where they are dealing with a enormous amount of people traffic, they are using the background NoSQL only. They're not using the RDBMS won't scale that vastly like NoSQL family. If you talk about example, I'm watching a YouTube, assume a case, every day. So I will watch what I'm interested. So Google is going to give you a recommendation what your interests are, how it is giving some recommendation to watch based on your previous history. So there are billions of people are watching the videos. How Google is actually giving a recommendation, how you Google actually, every user account, they are actually taking the data. Every click is a data basically for them. They will keep the data into the backend servers. They process the data using the intelligence. The background intelligence will take care of that. So billions of people are generating the data, and that data is, again, it's not a structured data. It can be any format, like video. They can upload document, they can upload any kind of data at any point of time. How that system is scaling up, giving you the response as well as your interested data all the time. If I'm watching example, my one of the interested area, maybe some interested channels I'm watching, similar channels, it will automatically give you recommendation. How it is actually detecting? Because there is something called intelligence, like artificial intelligence. It is working on your enormous data and giving you the suggestions. So that is possible through the NoSQL family only, not with RDBMS. It won't work in that direction. So all artificial intelligences are working on the NoSQL family only. If you talk about Facebook is something, like a social platform, and it is available around the world, and people are using it all the time. Still, you don't see the downtime, and all the people are seeing the response. How it is possible? Because hundreds of servers are serving your request in the background, not one. It is going to scale up like that.
Hi Ravi, I have one doubt.
Yeah,
So
go ahead.
in SQL Server, data is replicated from column-based filtering. So here, suppose three tables is there, A, B,
Mm,
C. A
mm,
table is 40 TB, and B table is 40 TB, and C table
mm,
is 40 TB. So
mm.
how redirected to first to second, second to third, that thing.
See, it is something you're talking collection level, a kind of table. See, if your one table becomes a huge and vast, then only you start the data. That collection will start distributing the load to other servers. As long as you don't shard, it won't distribute. But whatever the data you have, if example you are creating a replica set first, you're not distributing the data. It will sit in one server only, and that one server will replicate all of its data to here and here with all the data. Even this goes down, this will pick up. This is a traditional RDBMS technology. Like one replica set is equivalent to one traditional RDBMS technology, basically one replica set. Okay. So if you have 3 tables with a 40 TB, 20 TB, 30 TB something, definitely that is
Okay.
qualified to put into the sharding. If you put into the sharding, what happens? This technology, this is called sharding technology. It is going to share the data. 20 TB means, it is 5 TB here, 5 TB here, 5 TB here automatically. It will distribute
In
the
one,
data when you. Mhm.
yeah, even one table also it will distribute the data.
Yes,
One,
it is.
yeah.
It is a table level technology. What is growing bigger, enable it will distribute the data automatically. If you don't enable, all of the data will sit in one replica set only all the time. So that is not going to give you a performance. You have to tell explicitly this particular table growing the data, stripe it. I'll just run single command, it will automatically balance the data into all the background replica sets. You have to enable that manually.
In sharding part, I am asking that sharding. So one table
Yeah.
is there in first first box, and second box is B table, and third box is C table. Like that, it will get stored, or is any different way redirecting the data?
See, if you are connecting to directly this box and writing a table here, you can do that. Box directly, you can hit it. This is a B table you are creating it. C table you are creating it here. Assume a case, which means these are independent standalone replica sets. They are not under sharding. You're loading the data
Okay.
here. You're doing the sharding again. It is not going to make much sense if you are doing here itself. You create one more set of replica which is empty, then share it. You already have data 4 TB, 5 TB, 20 TB here. You're not going to make those servers into like other replica set in the sharding. You create empty shards and then distribute the data. It will go in that direction. First you keep whatever the data into one replica set. If the data is unmanageable, then introduce the empty replica sets, empty, so that there is a scope to distribute the data here, not in the existing one. If you are referring to each table into each different server, that each different server will fall into the its own sharding model if your data becomes more and more.
Okay.
Are you getting the point?
Yeah.
Right. So guys, try to understand. Just example, if you see, if it is a RDBMS model, if you understand this, the slides will become easy for you guys. If it is RDBMS system or Oracle, what happens, there is a concept called rack. In the rack concept, you can hit the multiple server for write operations, multiple servers at the same time. So, but it goes to one file system at the end in the background, one file system only. So you are bombarding one storage only at the end, not multiple storage. Anyway, they'll have their copy of the replica set. If this goes down, this will pick up the data. But at any point of time, one storage is available to write the data. Even in the SQL Server technologies also, you can write in only one server. At least the rack concept has multiple servers, one storage in the background. In SQL Server, only one server you can write at any point of time. Any technology, only one server you can write the data. Other servers will pick up the data automatically. If this server goes down, this server will be available immediately. And if the here, all RDBMS systems are core-based licensing model. They are very costly. They are not cheap at all. If you come to the MongoDB, it's not like that. If it is a community edition, see, there are two editions we have in the MongoDB. One is a community edition, one is the enterprise edition. Community edition will give you all the features that enterprise has almost, except a few things, and it is free. Free means absolutely free, no need to pay one single penny, and you can manage the petabytes of data. But if it is a community edition, you're not going to get the enterprise features like backup, automated backups, automated monitoring, encryption of the data, and there are few things are discarded. But data management wise, absolutely capable of the same data what enterprise can manage. All NoSQL families have open source technologies in every product. That's where people are showing more and more interest to save the money, as well as analytical data completely running on the NoSQL side only. All analytical data, whatever you see in the real world. See, any kind of platform, they are, every click you are doing, that is the data for the backend people. Based on the click, they are going to understand what kind of person you are, what kind of interest you have. Based on that, they're going to give you some suggestions. So the suggestions can be done by analyzing the vast amount of data, and RDBMS cannot scale with that amount of data. Only NoSQL family can do that. Okay. So this NoSQL is also a lot of, there are a lot of products, 20 plus products are there in the market, like Hadoop, MongoDB, Couchbase, and Cassandra. If you talk about RavenDB, there are many technologies are there, like into the NoSQL family. Why MongoDB is actually popular is next I'm going to pick up, because we need to understand the product, why it is getting adopted easily in the market. It is actually fulfilling a lot of business use cases, live requirements, like people are raising a lot of requirement, it is fulfilling it, so people are adopting it. How it is fulfilling, we are going to talk in the next slides. See guys, revenue wise in NoSQL family, Hadoop is the number one. Hadoop is a NoSQL family only. It is a topmost product in the NoSQL family. After Hadoop, the Mongo will come in the next, in the revenue wise, implementation wise as well, because it is fulfilling equivalent to, like the same use cases what is fulfilled by the Hadoop basically. So let's talk about this, guys. NoSQL means not only SQL. The full form NoSQL means not only SQL. You have SQL, which is RDBMS. Not only SQL means it is something reverse of it. You don't have any structures, nothing you have to define. It will pick up any kind of data and it will scale with hundreds of servers in the background to scale with the data growth automatically. All of this happen in the background. So not only SQL is a new databases that is not based on the relational database management principles. Management principle means this is what it is. Management principle. You create a table. You wanted to create one more dependent child table to, if I wanted to load the data into parent table, data will get loaded into child table automatically using the foreign key relationship. In MongoDB, you don't have any relations, any references in the MongoDB. You have something called embedded document, reference document, which is equivalent to relations what we have in the RDBMS. This product is absolutely different, structures. It will follow different principles. It will follow in the background. You don't have any fixed schema. You don't need to define. It is automatically create any schema that you wanted by the business. It will create automatically and pick the data automatically. So big databases, it will handle the big databases, means large, enormous data it can handle basically. And it is new SQL and new generation, third generation. See, these are the latest technologies, not old technologies in terms of, data usage. See, before NoSQL was introduced, like NoSQL was implemented, what used to happen? There were not too many mobiles, like if you see nowadays everyone carrying the smartphone, everybody is generating the data, which means that, so before, if you look at 15 years back, no one has a smartphone, just a small normal phones. They cannot generate data using mobile. Only they can make a call and receive a call, that's it. You cannot do a lot of activities using the mobile. Okay, so before 15 years back, you don't have a lot of data sources, you don't have too much of data in the system, you limited data. You can handle with RDBMS all of those data. Why? Because someone is entering the data, system is taking the data. Now it's not like that. Everybody have a mobile, everyone have their own personal devices to generate the data, and data is again wide variety. It's not one format. All the data, everybody is generating different kind of data. So when this kind of data is generated, RDBMS is not serving this purpose. That's where the NoSQL came into the market actually. Why? Because everybody is, like you are installing one app and doing some activities. That app is actually generating some recommendations, something for you. How it is doing it? It is reading your activities, your interest, your mentality. It is calculating everything about you. Then it is giving some recommendations basically. So the data, these databases are created for third generation, advanced generations, not for the previous old generations. The old generation has a limited data and limited formats. Fixed schema used to work for them. Why? Because once one person used to sit at the system, enter the data, but now it's not like that. Situation is changed. So if you talk about, 15 years back or 20 years back, if you talk about that, we used to have a very limited laptop, like laptop itself, we used to run with 100 GB. Now TBs of data is not serving the purpose. Why? Because data has grown a lot. You're taking your pictures, you're generating a lot of data. Every individual is generating the data, guys, not only one. Data requirement become more and more, and the services you come up, a lot of services are coming in the market with a lots of data formats. If you talk about, cloud technologies, cloud, you talk about OneDrive, that kind of technologies are coming a lot. Why? Because they have the data, people are loading the data, reading the data, so they are getting the money, they are able to get the money. So data generation, third generation database, why we calling it? Because data sources are grown, everybody have a data source now to generate. the see, if example I'm doing some business, if I'm doing some business, I need to know the people interest, what they're doing. It can be like a simple hit. If example I'm going to Amazon, if I'm trying to buy a product, I'm trying to buy a product. Next day, if I go and log into my Amazon account, it automatically giving you some recommendations based on what is the previous search, how they are doing it. Every account information, the clicks, and browsing history and everything, they are maintaining it and giving you some recommendations. How this can be done? It can be done using the intelligence, like artificial intelligence. Artificial intelligence is absolutely work with an NoSQL only, not with SQL. So these databases are created for the third generation, the latest generation. Non-relational, it does not have any relations basically. You go to each table. Each table is like here class and test, and each document has its own structure. We have seen that. So what exactly I mean to say here, you created some data, and this row does not have any relation with this row, absolutely independent. If example I wanted to load some data like this, maybe test and insert, one person have lot of different information. Example, its number, its name. Okay, example I'm giving Marvin, and location where she belongs to, kind of he belongs to, kind of. So location, he belong to country. I'm just showing you one example just for the sake of discussion. Okay, state something. If I enter this, if I read the data, if you see, and I'll give you Pretty to see the data in proper format. So if you see, first record has two fields. One is S number and S name. Second record has three fields. So this does not have same formats. If you see this one, four fields. If you see the fourth one, it has a altogether different structure. It is having embedded document. This is called embedded document. A document you have this outer layer document. Inside it you have one more document. This is called embedded documents. We're going to talk about a lot about it. No need to worry. I'll make you familiarize with all the terms and how you generate the data. Also, you can write your own queries. You can do the development also after my classes, because I'm going to cover you everything. You don't need to worry about that. First thing is, you need to understand each document is independent of other document. There is no interdependency. One document will hold all of its data. All the data is locally to, you keep the data to local to one document only. You cannot join this document and this document. There is no joining concept in the NoSQL family. There is no joining at all. So you keep all the information, whatever is whatever the information is related to this person, keep it in that document only, everything. Don't keep it somewhere so that you cannot join it. There is no joining concept in the NoSQL families. You cannot do the joining. You keep the data locality in the single document itself. That's where it is following like its own, every document is following its own independent structure. Your one person may be having two addresses. You might be having two addresses or two different phone numbers, something kind of. You enter information, all of you, his first number, second number, third number, whatever it is, you keep the data information about that person in the single document only. You cannot create into one more collection and join and get the data out of it. That's not possible here. Anyway, I'm going to talk about in the course why I'm wanted to explain. It's a non-relational. There is no relation. One document does not have a relation with other one. If you go to SQL Server, if I'm trying to insert one extra field, it is clearly saying that you cannot. Why? Because supplied values, actual values are not correct. Okay. If you see this, so if this is the case, if it is agile, the application nature is agile. Every day the business is like looking at different ends, different fields they wanted. Maybe they defined example char character data type. If they wanted to make it var because the data compatibility is not happening. If it is 1 TB table, you need a 1 day downtime on that. Changing the data type is very headache in the RDBM system. Really headache, literally headache. So that kind of maintenance is completely overcome with the RDBM systems, because one document does not have any relation. You don't need to define it all. First of all, it will pick up any data that you load into the backend system. Runs on the commodity hardware. You don't need to have server class hardware. You can even run the desktop, as you know, like Marvin was saying. If I wanted to run this architecture, I need 12 MongoD servers, 12 Mongo actually, and I need 12 machines. Yes, you need 12 machines, but they no need to be server class. They are the cheapest hardware. You don't need to invest much to build this technology. It can run on any hardware. Even in your laptop, you can make one node and then transfer the data to it. It is possible, and it will scale well. Why? Because you're distributing the data and picking the data from different servers, not in one server. It will scale with the lowest hardware, the cheapest hardware model also, because you're distributing the data and reading the data at the same time from all hundreds of servers and writing the data into all 100 servers in the background automatically. That's where you can run this product on the commodity cheapest hardware. It is possible. And the open source, this is a major point, guys. Everybody wanted to save the money in the market. They don't want everybody is doing the business just for the charity, not for the charity, to get the good amount at the end of the year so that they can project the good results. If they're showing the good results, their share value will grow. If it is growing, their company will become a rich. So everybody looking for the cost saving. So if nowadays, open source technologies are growing very fast. Why? Because everybody is looking for the cost saving, and that's where you're getting the jobs also. So MongoDB is an open source technology, and it is actually, they're given all features almost except a few 5-6 features. See, for example, 1 TB data or 10 TB data, 1 petabyte data, community free edition will scale with the data, and the enterprise also will scale with the data. All both are equivalently good to process data. What is missing is backups. Automated backups are missing by the product itself will take the backup if it is enterprise. And monitoring, if one node goes down, for example, in the replication, one node goes down, this will take up the role, and you write the data. But this is gone down, you don't get an alert. You have to prepare your own script to find out that. The MongoDB is not going to support MongoDB Corporation. Why? Because you're not paying them. Under free edition, monitoring is missing, backup is missing, encryption is missing, and some advanced feature or 2 or 3 features are missing. Other than that, data scaling absolutely equivalent as enterprise. If you talk about SQL Server, you have Express Edition. Express Edition is free, and what is the capacity of it? Maximum 10 GB now. 2 GB it used to be. Now it became 10 GB. If the database goes beyond 10 GB, it is not going to work. There is a clear-cut limitation. But here in the NoSQL family, all the products are open source. You can run all amount of data on the free editions. But there are some deprecated features. There's some features are discarded and kept in the enterprise. Why? Because they're developing and giving it to the market. Someone has to come to the pay, like a paper model. Like they have to pay money for the licenses. That's how they do get the money. So open source always has equivalent as enterprise editions, all products, if you talk about in terms of data handling, except some features. That's where this technologies are attracting the people to implement in the market. Schemaless, we have seen that, it is absolutely dynamic. You can create the table on the fly, you can insert each record, different structure, everything is, like not dependent on anything. You don't need to define anything in the background. It will do everything for you in the background. Irrespective of the structure, it will pick up the data, as simple as it is. Highly scalable than the RDBMS. How highly scalable it is? If it is RDBMS system, if your data is growing and bigger and bigger, when the data becomes too vast on a single server, you cannot do the maintenance activities. If you're not doing it, it won't scale. Scale means performance, basically. It won't give you the good performance. Why? Because data is become enormous on a single server. You're giving more and more CPUs, more and more RAM, good enough, but you're not doing the maintenances like rebuilding, reorganizing. You're not able to do it because the window is not sufficient to do that. If you're not doing it, your performance definitely will be degraded down the line. You see very bad performance out of it. But in MongoDB technology, it is a distributed model, distributed computing model. Basically, this is called as vertical computing. This terminology also very important. Vertical computing. We'll call it as vertical computing. Okay. This is called horizontal computing. Horizontal means you're adding the power in terms of the machine, not in some terms CPU and memory in a single machine. This is called horizontal computing model. Okay. So here we are giving the power in terms of machine. Here we are giving the power in terms of CPU and memory in a single machine. Vertically means you are giving the power in a single machine, scaling up, giving more power to the single machine. But here we are giving the power in terms of different machine. That is where the terms will change. Horizontal performance, horizontal computing model, this is a vertical computing model. These terms are important again. Okay, right, where I was. Right, highly scalable, highly available. Highly available, how do I say highly available? If your database, you stripe the database here and here and here, 3 files you have in 3 disk use place each file. If one file is down, the complete database is down. Complete database. RDBMS is something you have 3 files in a single database. One file is down, complete database will go down. It is completely not operational. If it is a MongoDB, if one complete replica set is down for some reason, one replica set is completely down, Mongo will not be down. It will operate with the rest of the replica set. Whatever the data is available in the rest of the replica set, it will operate with that data. You don't see the downtime. The downtime, if all servers are going down, then only it will be down. One set is also available. One set, whatever the data it has in the one replica set, it will serve the applications automatically. So there is no single point of failure here. You have multiple protection here. The protection, actually, if you look at, if this goes down, this will pick up the role automatically, and it has all of its data here, and it will serve the data automatically. It will become a primary, it will become a write copy, automatically giving the data to the applications. Even like you have it node level technology, node level redundancy, and each replica set redundancy also. What I mean to say, if it is standalone, single point of failure, one file is down, your database is down, and you lose all of your data. If that is not recoverable, you lose all of your data. You cannot do anything. You have to restore from the backup. And if you have a data gap, that data gap will come automatically. You cannot recover that. But here, if one chunk is down, one replica set is down, you still have all the data available and they are accessible live. You're not losing. You might lose this portion, but you don't lose this portion at any point of time. If it is RDBMS, one file is corrupted, the rest is gone. It is gone, as simple as it is. One file is corrupted, all the files will not be operational. You have to come through the backups, and the backup does not have all the data till the corruption, then you cannot recover. It is not possible to recover. You will see the data loss. In Mongo, it's not like that. It follow different availability. That's where it is highly scalable, highly available also if you compare with the RDBMS. You guys are following? Yes or no? Let me know, guys. If you are having a question, it's not one side kind of, you can ask any kind of question. I'll pick up that. Okay. Okay. Right. Let's move on if you don't have question. So support base properties instead of ACID properties. What is base property? We're going to see this, guys. This is actually ACID properties. What happens? We're going to see in the base property what is going to happen at the end of the slide. I kept it, no need to worry. Mostly runs on the cluster to give this high availability, high scalable architecture to get. You have to run the cluster. This is called sharding cluster. We call this technology as a sharding cluster. Okay, if you're not implementing the sharding cluster, you're just implementing only one replica set for some reason, then if this is failed, this is available, this is failed, this is available. If this is also failed, you will lose the data. Even in the RDBMS system also, you have one server, you are keeping the secondaries. If primary is down, secondary will automatically take up the load and running from there. The same thing you are following in the MongoDB also. But if you're implementing the sharding, that's where you're going to get the high scalable data, highly available data, all that in the cluster. Built for new generation application, latest generated application. It's not for the old generation. Old generation does not have too much of data from the data generation wise, where there was a limited data. Now it is enormous data and variety of data. That's where this coming into the picture. Why NoSQL again? See, guys, whatever I discussed, again it will come here. Resolve the challenges faced in the storing, managing, and analyzing and archiving the data. So this is something, you can store any kind of data and you can manage it. Absolutely, you can analyze it and you can archive. Means, example, you can use a MongoDB like this. You are running the SQL server, live, and you wanted to archive some years of data, like 10 years, you have 10 years of data in here. You wanted to send the, like you can take all of the data from SQL server, you can archive into Mongo, like 7 years of data I'm archiving into Mongo, 3 years I'm keeping in the live database to offload the database. So like that also you can use the Mongo. We are using in our company actually. Mongo is a backend technology and SQL is a front end, and all historical data we are pushing it to Mongo and keeping there, and serving actual live data will be on the live database. If you wanted to pull the data from SQL server, how do you pull it? How you can convert the Mongo data into SQL data into Mongo? We have a project. I'm going to talk about that because I did the migrations from Mongo to SQL to Mongo, Mongo to SQL. Both I'm going to talk about, so that you can offload the SQL server to load the data. Archive data means old data, unnecessary data, and whenever it is required, you can pull it back to the live database and serve the applications. That you can do it. How we do the conversions? I'm going to take it as a project. We have that migrations. Okay, so that way you can do it, like archiving the data and storing and managing, analyzing. This large amount data it is analyzing. So that is what analytical data is. All analytical data running in the Mongo or the NoSQL family databases only. Social media like Facebook, Twitter, with a large amount of data needs, definitely they have to come to the Mongo, the NoSQL, not only Mongo. Maybe they can go to the Hadoop also, whatever it is, but they have to dependent on the NoSQL family only, because every user, what kind of data they are going to load, the provider does not know. It can be text data, it can be video, it can be unstructured data, like unstructured means anything, any no format at all, just they are writing something and loading into it, it is taking it automatically. So any kind of data it is accepting means they are using the NoSQL technology only in the background, not RDBMS. Need of continuous availability. If your applications are not giving the availability, you lose the business, as simple as it is. You don't get the availability, you cannot sustain in the market. So it has to be available all the time with all the data. So that's what is happening in this technology. If one server goes down, other one is become the primary and giving the giving the purpose. So the end user does not know that there is a failure happen, something is down kind of. Highly available technology it is compared to RDBMS. Mongo, the NoSQL families are absolutely highly available than the RDBMS. Why? Because every node has its own protection layer as well as data distribution. Both you have two things embedded into it. This kind of architecture you don't have in any RDBMS system. No technology, no RDBMS have this kind of architecture now in the market. So need of continuous availability, it is giving the continuous availability. Why? Because multiple nodes are giving the purpose, doing the purpose. Need of more flexible data model. You don't want fixed schema. See, if you are generating the application logs, maybe you wanted to see the application error rate, application how many times are it is erroring out. You cannot do on the SQL platform. You definitely use Flink school. There is a tools, Flink, and if you have go to multiple tools, they deal with some, tools will pick up the data and load into one of the NoSQL family. From there, you analyze the data, you look at how many errors are generating each day, how many successful connections, how many error connections, all that you do on a dashboard, where you are searching all of its data and generating one particular dashboard. That is intelligence, artificial intelligence. That is called artificial intelligence. They'll write some algorithm go and read all of the data and give you one final report, like these many errors are occurring in the logs. Application data or streaming data, like whatever you are generating, some you are clicking the website, that is also a log. Every click is actually recorded in the background, what you are hitting in every website, and that is traced and loaded somewhere. Based on click means based on your interest model, they are going to give you some suggestions. If you are if you're trying to buy a car and you're going to the car website and clicking it, your click is actually recorded somewhere in the system, and they are going to give you some recommendation, the variants, similar variants of other manufacturers. How they are giving it? Because they are tracing your clicks. How the artificial intelligence is working? Because every click is the data, the click is something, every click can have a different formats in the background. So that is not served by the RDBMS. It definitely a NoSQL family in that direction. Artificial intelligence only working on the NoSQL family, not on the RDBMS, as simple as it is. The NoSQL database, great solution to growing scale of databases and falling prices of the commodity hardware. See, pricing the commodity hardware means the cheap hardware is falling down the prices wise. If you see, if you talk about a pen drive itself, we used to get with very higher cost. And 10 years ago, 4 GB pen drive you used to get 1,000 rupees. It is very costly. If you pay 1,000 rupees now, you'll get the 64 GB, 4 GB to 64 GB. The commodity hardware, the cheapest hardware, actually becoming lesser and lesser day by day. See, if you wanted to buy 1 TB hard disk at 10 years ago, it used to be 10,000, even 10,000 also, that availability is not there in the market. Now it is widely available and at cheaper cost. That's what it is saying about commodity, falling the prices of commodity hardware. If it can run on the commodity hardware cost is going down, you're saving the money, as simple as it is. That is what it is talking about. Commodity hardware, falling the price of commodity hardware is fetching the point, it is saving the money for your business if it is able to run on the commodity hardware. Consists of column-based data stores, key pair values, databases, and document database. There are different types of, again, there are multiple different, like families of NoSQL databases we have. We're going to see in the next slide anyway. Offers capabilities to handle the large amount of data using the various available features. Using the sharding here, if you talk about different technology, they have their own sharding model. Again, every technology has this kind of sharding model to deal with the large data, right? So continuous availability, no single point of failure. So no single point of failure means if one server down or one file is down in a database, your database is out of operational. But here it is not like that. Continuous availability, it will be there in the no single point of failure. One file corruption is not going to bring down the complete database. In the MongoDB, it's file corruption means here replica corruption. You can say their file, here it is a replica set. One replica set is corrupted, it is completely out of operational, still you can operate with the available data from the other nodes. That is giving you the continuous availability. And no single point of failure means no one replica is down, which means that you're not bringing down the whole cluster. Other machines will work. Multi data center capability, anyway this is there in the RDBMS system also. Multi data center means this is in one region, this is another region means maybe one is in East US, another one is West US. It is possible. Multi region replica sets are possible. We are going to configure, I'm going to show that how do we configure multi data center replica set, how do we migrate one data center to other data center, how do we upgrade from one version to other version, and what you need to take as a precautions, what are the steps are involved to do the upgrades. All that will be discussed anyway. Easy replication for distribution replication. See, easy replication, distributed location, independent capabilities. See here, it is simple. One command is going to configure the replication, one single command. If it is RDBMS, there is a complex of steps you have to follow. You have to follow a lot of steps, then only the configuration will be completed. In Mongo it's not like that. Configurations are dead simple in Mongo. Only the underlying architecture you need to understand, and fixing the issue, that's where the actual experience will come into picture. In NoSQL family, all NoSQL family, they did not make the configurations too complex. They are very easy, anybody can do it. If they see once, they can do it the next time, as simple as it is. But when it comes to the issues part, you need to understand the background, then you can respond to the issues as they arise. Basically, that something is required. High performance with a linear horizontal scalability. Linear horizontal means, you see, we are adding the power in terms of machine, you are able to get the high performance though the data is keep growing, because hundreds of servers, lot of servers are serving your purpose. You're writing the data, 4 servers are getting written, you're reading the data, 4 servers are giving you the response with the independent data. That's where you're getting the good performance in the front end. Flexible schema support, no need to, it is a schemaless product or dynamic schema. We see these words, schemaless product, there is no schema, there is nothing you have to define, it will pick up any data, and it is flexible. That kind of flexibility is giving. Easy to implement, maintain, and grow. It is very easy, and maintenance is also simple. It does not give you too many issues basically, but anyway there will be issues in any technology. I'm going to run through all the issues that we see encounter in the real world. Driven open source community. So this is something, another big point why people are moving it, because it's open source technology. Open source, it is giving all sort of features except some enterprise features. And what is enterprise features that is not there in the community edition, we are going to see. See, community edition will give you sharding as well. If you talk about RDBMS express edition, you cannot do the replication, you cannot do the mirroring, you cannot do the lock, you cannot do any technology on the free editions, free versions, free editions of the Mongo. Sorry, RDBMS, or if you talk about any technology, if they are giving you some version as a free, even Oracle also enterprise, whatever the enterprise is, the free does not have any features, just a plain. You cannot implement any technology and the free editions of the RDBMS systems. In NoSQL, it's not like that. The scene is reverse here. Why? Because you can do all technologies with the community edition. You can form the sharding, you can operate petabytes of data. There is no issue. Only issue comes when the issue comes, MongoDB will not support. It's a community edition, you are not paying anything. We are not responsible for any of your issues. If you had to get our support, pay it. Pay and get the support. If you go to the enterprise, pay the licensing, we'll give the free support. There are two ways, guys. If you're running the community edition, if you wanted the support from Mongo, you had to pay for the support. If you go to the enterprise, you're paying for the license, we'll give you free support. Either way, they had to get the money, right? That's how they sustain. That's why they are releasing new features, new versions all the time. They're investing a lot of money in that direction. If they are investing, they had to get some money from market. How do they get? For the support. For community edition, you need to get the support. For if it is some buggy thing is there in the product, the technician cannot do anything. Only product guy has to help. If bug is there and the product guy, you're not paying it, they don't solve it. As simple as it is. So either you have to pay for the support or pay for the licensing. Support is anyway cheaper than the enterprise licensing. That we'll see anyway how the licensing works in the Mongo. Now the comparison in terms of words, guys, RDBMS, if you pick up this is a rigid schema, fixed schema. It won't, you cannot load the data what you wanted. You have to define the structure and load the data which fit into that structure. You must follow the structure what you define, as simple as it is. If you don't follow the structure, no, you cannot do it. That's what rigid structure, rigid schema, fixed schema. Here dynamic, you can pick up, you can load any kind of data, it doesn't even reject you. If you wanted to get the rejection, you have to define the validations, schema validations. Schema design is the fifth module for us. I'm going to explain you. See, if Mongo is taking any kind of data, bad data also, then it is going to become unnecessary vast. No, I don't want that. If the document, if the table is falling in this kind of structures, then only pick up the data. So that also you can keep it. Maybe sometimes dynamic schema is also a bad advantage for some reasons. I'm going to explain that. And there you can make this fixed. You can create the validations. If this comes, then only accept. If it is not there in the incoming data, don't accept it. We're going to see that in the schema validations anyway. Vertical scaling, this already I said. This is following the vertical scalability. Why? Because you are giving the power to single machine to sustain with the data load. Single power, you're giving more and more CPUs, more and more RAM as the data is keep growing it. If it is a NoSQL, it is a horizontal. Horizontal means in terms of machines, you're giving the power to the system to scale. Difficult to handle big data. Big data, it is handling the big data. Definitely it will become a huge pain. When it becomes a huge pain, when the data is enormous on a single system, you cannot do the indexing. That is a main big problem with the RDBMS systems. If data is vast, it will scale good enough, but down the line you cannot do the maintenance activities like rebuilding, reorganizing indexes. If you cannot do that, though you deploy the highly powerful machine, still it cannot operate well. Why? Because it's going to read a lot of data, unnecessary data, because data is fragmented already. So it is going to degrade with the performance, though you keep more and more power on the single machine. That is what big data is difficult to maintain in a single machine in the RDBMS. Mix of open source and proprietary. There are open source, you have open source, but with a limited features, not all. You don't have all the features in any free open source in RDBMS model. In Postgres, MySQL open source, good enough. Okay, they are actually like this, but they have the buggy products. And if you wanted to go to the supporting model, there are different supports anyway. Third-party supports are Oracle. If it is MySQL, Oracle do the support. If it is a Postgres, there are a lot of third-party people do the support model. Again, it won't scale with the big data. It won't be follow the dynamic schema, all that. Okay, that is there. It's open source. purely open source. You can run all your environment. See, in our environment, 80% of the servers are open source servers. Only 20% are enterprise and licensed. 80% production servers I'm talking about. So we no need to spend all the money on the licensing model versions. Absolutely, you can run your business with the 20% licensing model, 80% open source. You're saving a lot of money. And also, compared to licensing model, all RDBMS systems will follow the core based licensing model. How many logical CPUs you have, that many licenses cost you have to pay in RDBMS systems. Mongo is not like that. It's a RAM based licensing model. Okay, that's where you get the another benefit. You can run the 80% of the 80% of the infrastructure on the free versions, community edition, and 20% also you, if you compare with the RDBMS, lesser licensing cost. So it is saving you in all directions anyway. Mostly standalone. Mostly standalone means only one machines will be written, other will be one machine. Standalone means what? One machine writable, other machines are readable, which means it is standby always, but at any point of time you can only write one machine. That is what is called standalone. Here it is distributed cluster. Distributed means multiple servers are doing the job for you all the time. That's what it is saying it. Single point of failure. One file is down in the database, complete database will be down. Single point of failure of a database of data. And here no single point of failure. Even one replica set is down, other replica sets will keep operate the data what they have the data with. Okay. And ACID property. In the next slide I'm going to talk about the ACID property anyway. Need server class hardware. Highly sophisticated hardware is required to scale with data. Here you don't need it. Commodity hardware. Any cheap hardware you can run this product. It is costly. Maintain to licensing model and to get the OSS model. You know, everything is costly in this model. If you talk about this, the cost is average compared to this one. Even you compare the licensing to licensing, is average. It is costly. If you compare with example, if I'm paying $100 for the RDBM systems, if it is a Mongo enterprise version, you will pay 45 to 50% straight away. 50% rebate, 50% discount you are getting if you are using this one. And the licensing model I'm talking about, free open source anyway, it is supporting everything what enterprise can support except few things. That way, the NoSQL family gaining the more market nowadays, because kind of flexibility it is giving the open source technologies for you, and it is giving you all the ways to save the money. See, this is types of NoSQL: key value pair, document based, column based, graph based. These are the 4 different types again we have in the MongoDB. And Redis, see, under key value pair, Redis server and Memcached, Scholaris. These are the 3 different products under this model. And document based, MongoDB, CouchDB, RavenDB. These are the 3 different technologies we have again. Column based, column based, Bigtable, Cassandra, HBase, Hypertext. These kind of technologies we have in the NoSQL again, and they fall into these different families. But MongoDB highly implemented after the Hadoop actually. Why it is so? Because it is fulfilling lot of business use cases. It is actually serving the purpose what they wanted. That's where the MongoDB is gaining more market, and they are giving you lots of new features month by month, year by year. Okay, they have introducing every new version after every 6 months or one year. So they are working rigorously to make the product much richer and to sustain, to match with the market requirements. So if they are releasing new features means new versions means they are giving you, they are working with the more and more new feature that market required. So what is big data basically? In terms of big data, see, all NoSQL family products will handle the big data. What is actually big data? Again, it's a question, right? Big data means it is something, see here. Big data is any data that cannot be handled and processed through traditional systems. Big data means cannot be handled by traditional RDBMS systems. One machine cannot handle it, all the data, because data is enormous. People are generating the vast amount of data. Okay, that cannot be handled with a traditional system. Big data involves millions of users, millions of queries per second, billions of rows of insertions, updations, deletions at the same time, variety of activities at the same time. People are doing different activities, like billions of people. Facebook, if you take about around the world, many people are accessing at the same time. You never see the latency, you never see the portal is down at any point of time. How it is possible? It is possible using these technologies only. And if you talk about this, it is actually handling with a large volume of data and a variety of data. It can be structured, semi-structured, unstructured, whatever it is. You load the data, it will accept it. It does not matter what kind of data like model it is. Like it can, if it is RDBMS, it is fixed. It is only structured data it can handle. It does not structure, it does not handle with the semi-structured, it does not handle with the unstructured. Unstructured means there is nothing, there is no rule for the data format. It can come with any format you wanted to take the data, and RDBMS cannot take that data, only NoSQL. Velocity means speed, performance can be given irrespective of the data size. You keep add more and more replica sets, the data will get distributed. If the data is getting distributed into more and more nodes, you get the more and more performance. Like that, you will scale with the as data is keep growing, you keep adding the replica sets more and more, you get the more performance. So vertical scalability, increase the CPU, RAM, disk in a single machine. Okay, high cost. Why? Because if you are keep increasing the more and more CPUs, more and more cost you are paying it. As simple as it is. Downtime. If you wanted to do maintenance activities, you have to take the downtime, bring down the machine, all that. In the MongoDB, it's not like that. If I want to do some maintenance activity, I'll fail over to here, and then cluster is operating, and I'm doing my own activity here. Once it is done, I'll fail back, and data will automatically flow in. So maintenance wise on all nodes you can do the maintenance without a downtime. No downtime required. Why? Because here multiple data sets or multiple replica sets are working. Each one has its own standby machines automatically again. So in standalones you need a downtime. Definitely. Threshold and limitation. You can operate certain amount of data. If example, I can operate with a RDBMS maximum 20 TB, 30 TB assume case. If it goes up to 30 TB a single database, you cannot maintain it. Definitely you cannot maintain it. You have to archive it to old data, or else you have to divide the functionality of the application into multiple different databases. If not, you won't scale up. That's what it is. Threshold and limitations. Single point of failure, one file is corrupted, the whole database will be down. That is another point. And horizontal, see, add more machines, more performance, as simple as it is. Less cost, commodity hardware, any hardware it can run. Like as I said, the commodity normal hardware, the hard disk hardware type is very cheap nowadays in the market. It used to be very costly, now it become widely available and cheap. That's where you're going to save the money again. No downtime, no limitation. There is no limitation for data. They did not give you, this is the limitation you can scale up to. After this it won't scale, kind of. They never give a figure. It will scale irrespective of the data, as long as you keep adding the more number of nodes to scale with the data. But they are not telling you that this is the last final limitation. Beyond it, it is not going to scale, kind of. It will scale at any point of with any data. No single point of failure, can be scaled down. Okay, can be scaled down means it can be scaled with the, and it will give you performance. That means that. Right, this is what anyway, we have 3-4 slides. We are close to the class anyway, so I'll this is the last slide for us anyway. So see here, RDBMS will follow the atomicity model, and this is following the base model. Basically, available soft state eventual consistency, base full form. Asset properties, A stands for atomicity, C stands for consistency, isolation, durability. What is atomicity saying is, a transaction must be committed or rolled back. It should not be left in the half done status. No transaction should be left in half done state. It must be committed or rolled back. If it is uncommitted, if the system is shut down, when the system came online, it automatically revert the data or commit the data based on the final status of the transaction. At any point of time, transaction should be it should not be in half done status, which means that it is finished some half job, it is failed, it roll back because it did not do all the job. And if it is did everything and then commit and apply the data, all the data, but it should not be in a half done, means it should not be at any point of time, it should not be left in a middle of the action. It has to be either complete the action or fail the action completely. Consistency means data should be always same. See, example, I have done I'm running a batch and 50 records are inserted, 50 records are yet to record, and the system is rebooted all of a sudden. When system comes online, the 50 records will roll back because it's a batch, and the batch, if it is failed in between, It is taking care, the rolling back or rolling forward, the consistency will take care of it. At any point of time, data is correct. Whatever the system, if system is failed, you inserted a batch is failed, but 50 transactions are already inserted, committed. But when the system comes online, the end status of the transaction is not completed. It will roll back automatically. So it will maintain the consistency of the data. Isolation means one transaction at a time when it is writing. No interference. If one is writing, other one is also writing. What is end status of the database or end status of the data? You cannot guarantee that. So that's why every write operation should do the action, like isolated way. I means single operation is allowed on a writable data, not multiple at the same time on the same segment of data. It is mandatory that you have to do one action on one database, kind of one action on the write on one table, one portion of the data. Durability means whatever you written, it is absolutely permanent. Once it's written, data is permanent. Data will not change on its own as long as you're not changing it. You're writing data today, you're not doing anything, you're reading after 10 years, 20 years, 100 years, data is same. It is durable, it is written, it is made permanent to the data, to the disk. Whatever the data is there for years, whatever it is durable. As simple as it. It won't change on its own as long as you are not changing it. This is something basically available. Soft state eventual consistency means in RDBMS we have a synchronous commit basically. If you write data here, it will be definitely available here at any point of time if you go with a synchronous commit. In MongoDB, you don't have a synchronous commit. You write the data here, it will go to the secondary nodes in asynchronous manner. It is not immediate. It can be immediate if the network and the machines are capable of picking the data. If the network bandwidths are not good to pick the data, it can be delayed with the data. It is possible. Delaying of data is possible. That's what it is saying, that basically available, but soft state eventual constant. Eventual means not immediate, but eventually it will pick up the data with the primary. If it is a replica set. It is talking about the replica set case. If you're writing the data, this data can be immediately available, cannot be immediately available. It is asynchronous by nature. It's not synchronous. You can make it synchronous transaction wise. You can mention in the transaction, I wanted the synchronous data. Synchronous means it's a transaction level. In RDBMS, it's a server level feature. You mention at server level whether it has to write all the data synchronously, all the data asynchronously. But here you can mention at transaction level. I wanted this transaction should be committed in all replica sets, can give me the response. You can mention that in the transaction. The majority of the write majority, read majority, we're going to talk about in the module anyway. I'm going to explain, but this will follow this model. Basically available soft state eventual consistency. Okay, this is something is a NoSQL family will follow. Next, this is the last slide for us anyway. MongoDB used to call as Tengen before MongoDB incorporation was formed. It is anyway Tengen renamed to MongoDB, as simple as it is. It's not developed by someone. It is developed by MongoDB only. And MongoDB is completely owned by MongoDB incorporation. Nobody is owning it. No third-party tools are there in the market to support directly monitoring, backups, and all everything. Is only MongoDB tools are available, like Atlas, Ops Manager, Cloud Manager. There are three tools to maintain the enterprise versions that will give you a lot of automation. If it is Atlas, if the disk is full, the disk will automatically extend. You don't need to monitor anything. It will take care of everything. You just load the data, as simple as it is. Even the machine is down, it will auto repair everything. It does automatically, repairable tools we have it. Atlas, Ops Manager, different tools we have. We're going to talk about that anyway. So object structure document stored in a collections. Each object has the primary key called object ID. Anyway, if you see, when I'm reading this, everything has an object ID. This one I did not insert. This has a lot of meaning. Using this, we can troubleshoot lot of issues in the Mongo. What are the issues we can troubleshoot using this value? Anyway, we're going to pick up in the module, and that is mentioned here. It is very, very important. Manipulations with objects in the collections, find objects, and you can do all inserts, update, deletes, all modification that you do in RDBMS. In the MongoDB also you can do it. But the problem with the MongoDB is it does not follow the ACID properties. What is ACID properties? I just said this thing. If a transaction is 50, you see 100 records it has to modify. It is executed up to 50 and it is failed. When it comes online, it won't recover. Once it is committed, means committed. There is no rollback in the Mongo. You have to verify, okay, 50 records are committed and applied to the database. Okay, I have to, if the system came online, it is failed, but came online, 50 records I have to insert. 50 records are already inserted. So you have to verify till what point it is executed and failed. So whatever the point it is executed, it will apply it is permanent. There is no rollback mechanism in the Mongo or on all RDBMS, on all NoSQL family. That is a big drawback, still is not filled out. Maybe definitely it will be filled out in the near soon. They are working on that direction. This is another big disadvantage for the NoSQL family. That's why RDBMS is sustaining. If these people are introducing this thing also in the NoSQL family, RDBMS will be gone. They had to either compromise the licensing cost or to sustain in the market, or they had to close their companies. As simple as it is. See, nowadays is MongoDB era and NoSQL era. Why it is NoSQL era? Because data is coming in a different formats. There is no fixed format. There is a fixed format, then go for the RDBMS. If there is no like no fixed at all, and you're dealing with a wide variety of data, go to the NoSQL family. This kind of choice are people having it. That's where NoSQL family technology, adding it to NoSQL family technology into your profile becoming mandatory nowadays. It is getting implemented everywhere because of these reasons what I discussed, all of that throughout our discussion. I did not pick up any technical terms today, nothing much. It is just information. What is a NoSQL? You should get an idea now. All the NoSQL are schemaless, dynamic schema, and they scale with enormous data. They have the more availability, more scalability compared to RDBMS. These are the main points you have to pick up out of all discussions, especially. Right? So that's all from the demo point of view. Anyone have question, let me know. I'll pick up the point question by question. I'll then close it off. Anyone have any question? You can ask anything, guys, that you have in your mind. Then I'll talk about that and close it off. No one have question? So what I'm going to cover in the next class is I'm going to cover complete Linux basics. First, many people are not from the Linux background. I'll spend 3 classes on all the ground activities, like as a DBA, what level of Linux knowledge you need to have, that I'll completely cover. Then I'll start the product anyway. You don't need to worry about platform, like underlying OS. I'm going to cover all as a DBA, what and all you need to know. I'll cover up all, then enter into the product. Right. So I don't have few people contacts. Who this Jagan M. JGANM. I don't have this contact.
In the enterprise edition, what are the tools it will comes as compared to?
Enterprise in edition.
As
enterprise
compared
edition,
to a community version and enterprise version.
Yeah. See, enterprise has
Yeah.
you can take the automated backups using the third-party tool. Like third-party, it's not a third-party MongoDB tool itself. Like Ops Manager, Atlas, Cloud Manager. There are 3 tools which will be fully automated. It can take the automated backups, automated point-in-time restore. Automatically, if you click one click, it does the complete
Your
restore.
voice is breaking.
Voice is breaking. Was it from the beginning or just now?
Now fine.
Yeah. See.
Now fine. Now.
Right. So, can you repeat your question once, please? Quickly. See, enterprise actually, enterprise is giving you a lot of advanced features like encryption of your data, encryption at rest. In the background, all data will be encrypted. Even if someone is stealing your data from your hardware, they cannot see it. And monitoring. If one node is down, that will be notified through the tool automatically. That is not there in the community edition. And you don't have automated backup, and automated recovery is not possible in the community edition. Basically, these are the main components you are not having in the community edition. And enterprise edition, if you have the Ops Manager, Atlas, they are compatible with only enterprise, not with the community. That's where the enterprise and community trade-off. But in terms of features, general features, everything is there in the enterprise and community edition. Like you can do the sharding.
Ops Manager?
What is it is an on-premise tool. Atlas is a cloud tool. On-premise is one of the automated tool where you register. Oplog is a replication in when you build a replication technology, it will push the data. See, data is moving from here to here through the oplog only. That is a lengthy concept. I'll cover in the replica set configuration. We have a separate module for that. I'm going to spend 5 classes on the replica set. No need to worry. Oplog is something you're talking about the internal subject. Now it is demo, right? So we're going to talk about that in detail. Of replica set, data is moving from one node to other node using the oplog only. Without the oplog, it won't operate.
Hi Ravi, I have one quick question. So,
go ahead.
It's related to backup actually. So in ODBMS we have like a log backup, differential, full backup. So hourly transactions, like I can take a log backup, right? So ODBMS like that. Mongo, there is any technology to take a hourly backup voice like that? Because in our organization we are completely taking a disk level snapshot. So there is any technology like that, or still it is not there? So
actually, you don't have that kind of backups here. You have a full dump or else oplog subsequent data transaction oplog backups. Oplog backup will cover all the transaction that is happening after the dump. Basically, it's like equivalent to your transaction log backup in the RDBMS. There is no differential concept in the Mongo. Full backup, and you can say that transaction log backup. Oplog backup is equivalent to transaction log backup. We can recover the data using the oplog manually in the community edition enterprise. I'm going to talk about as a scenario this thing. How do you recover the data in the Mongo if it is corrupted at any point of time? The recovery of the data, how it happens? You can do it all the recovery if you have the proper backups. So how do you do that is something we have a discussion, is a scenario based discussion. What you are asking.
So
anyway,
so the oplog, like it's a transaction log backup, like so if I need to restore like particular time, I need a old oplog and oplog. That's like correct. Same kind of thing.
Right, that's correct. I'm going to show as a scenario anyway.
Yeah, got it.
Right, that's a good question. Any other questions from anyone? Any question that you have in your mind? We'll talk about it. Right, if you're good enough, then we can close this for today. And every Sunday we don't have class, guys. Every Sunday we don't have class. Let me stop the recording.